Hey guys, what's up? Welcome to the first video in the alkene addition set, and this one is going to be all about carbocations. Okay, and so let's first talk about what a carbocation is. Right, a carbocation is a carbon with an incomplete octet. You've seen it before, it has this positive charge. Okay, and so it can form through a bunch of different other ways. And so we're going to be showing mainly just how it can form, and in the later videos we'll get into all the things that uh, are associated with them, like what they can do. All right, and so let's get into it with just a quick example. I drew out an alkene over here for you guys, right? And we're going to react it with a compound. Let's just write HCl. Now, all these alkene addition reactions and the type of them, I will be going through them in future videos, but I am going to have to use an example of one of them just to kickstart the carbocations, all right? And so this is something you've seen in lecture. You might have seen it with a bromine. I just put a chlorine, it's all right. And in the next videos, I'll be going over like the exact types of them, so don't worry too much about the type of reaction in this case, all right? We're mainly just focusing on the carbocation. And so how does this reaction proceed? Well, the double bond is going to attack that proton. It's going to reach out, it's going to attack that hydrogen. And remember, a hydrogen can only have one bond at a time. And so because we're forming a bond with that double bond, we have to break the hydrogen chlorine bond right over here. Okay? And so let's redraw our products. Always easiest to draw what you know didn't change, right? And so let's remember that this chlorine over here had 3 lone pairs. And so what happens is because it had 3 lone pairs and the double bond is going, sorry, not the double bond, the single bond is going to break and go onto the chlorine in the form of a lone pair, our chlorine is now going to have 4 lone pairs. And if we calculate the form 1 charge, it's going to be negative. Okay? What about our alkene? Well, it grabbed the proton, right? So it's going to have a hydrogen added to it. So where exactly is it going to add? So we have 2 options, right? The way that we have to think about this is the double bond is going to disconnect from one carbon and stay connected to the other and form the hydrogen bond there. So let's draw the 2 possible ways we can do this. We can either have the hydrogen form here, right? And we're going to be left with a positive charge over here because it has an incomplete octet. The double bond broke from it, right? Or we can form it right over here and be left with a carbocation over there. All right. And so which one is it going to be? And actually first, in case you guys are having kind of some trouble visualizing how this all happened, right, try to think of it like this. So we have our double bond, we have the hydrogen we're going to grab. So essentially what we're going to do is it's going to disconnect from one carbon. Let's say, sorry, let me redraw that. So let's say the double bond will disconnect from that carbon, and it's just gonna, so it's gonna remain connected here, and it's just gonna pivot over there. Okay, so essentially it's gonna swing out this way, and it's gonna swing a little bit more until it's coming out and grabbing that hydrogen. All right, so that's why one carbon still has that bond, it retains it. The other carbon is going to be deficient now because it lost that double bond, and it's now going to have a positive charge. And so which one is going to form, right? So the way that we have to talk about carbocations is we talk about them in terms of the substitution of the carbon that they're on. What does substitution mean? It means essentially the amount of non-carbon groups coming off of it, okay? And so if we look in the context of this one right over here in red, our carbocation has 3 carbon groups coming off. One here, one over there, one over here. So we call it a tertiary carbocation. The one at the bottom has 1 carbon group coming off, a second carbon group, and the rest is just a hydrogen. So it's a secondary carbocation. So the question is, will the tertiary carbocation form or the secondary? So carbocations only form on the most stable carbocation is the one that will be forming. So we need to determine which is more stable. And the key feature that's going to determine this is if we can stabilize the positive charge. All right, similar to when we did acidity questions, that the more acidic hydrogen is when we depronate it, we can stabilize our negative charge. The same concept runs over here. We need to stabilize our positive charge, and that's going to be the one that's forming, the one that's the more stable one. And the key thing to do this is to look at our alkyl groups. Okay, alkyl groups, like methyl groups, ethyl groups, they are electron donating groups. Okay, remember, electrons are negatively charged and they're attracted to electron deficient or positive molecules. Okay, and so if we look over here, let's erase this. So now if we look over here at our top molecule, we have a carbon group donating electrons that way to that positive carbon, another group donating it that way, and another group donating that way. So we have three three electron donating groups that will help stabilize that positive charge by making it less positive, bringing it a little bit closer to neutral. Okay. If we look at our lower and our secondary carbocation, it has one group donating and a second group donating. Okay. And so that means our tertiary carbocation has more electron donating groups on it, and therefore it is less positive and more stable. Our secondary carbocation has only two, so it's more positive than our tertiary carbocation, and therefore a little bit less stable. Okay, so that means so like we just said, our tertiary carbocation is the more stable carbocation, therefore it is going to be the one that forms. And so the hydrogen ends up on that carbon right over there. All right, and so since that's going to be the one that forms, let's just erase what we have here. And I'm just going to clean this up a little bit. Let me redraw it. We're going to have our hydrogen coming off of here and our positive over there. Okay, and so the next step in this reaction is that because that is a positive carbon, right, it's electron deficient, electrons will be attracted to it. And that chlorine with the negative charge is full of them. So it's going to come in and attack that positive charge. And we're going to be left with this molecule here. Okay. And so that's the basics of how a carbocation can form. In the next video, I'm going to be covering the, what's known as carbocation rearrangements, or at least, actually, I want to talk about stability of carbocations first, and then we can go into how carbocations can actually rearrange themselves within a molecule. Okay? And so if something in this video didn't make sense, please feel free to email me or talk to a TA in the CLC. They'd be happy to help you guys. And I will see you in the next video.